NASA has re-established communication with Voyager 2 after months of being unable to connect with the record-breaking interstellar mission. It remains the only spacecraft to have visited both gas giant planets. Voyager 2 was the fourth of 5 spacecraft to reach solar escape velocity and leave the solar system. The Voyager 2 spacecraft from NASA is the second to enter interstellar space. Keep watching ahead and we'll tell you more about the Voyager 2. Hey there everyone, hello and welcome back to our channel. In today's video, we'll talk about Voyager 2's sending back new outer space images and revealing secrets of the universe. But before we get started, subscribe to our channel and hit the bell icon to never miss a video from us. That said, now let's take a look. While both robotic explorers have faults, the Voyagers still have some working sensors and send crucial data back to Earth on a regular basis. The Voyager 2 spacecraft is approximately 128 astronomical units AU from the Sun, with 1 AU representing the normal Earth-Sun distance. That is around 3 times the distance between Earth and Pluto. Any radio signals sent by Voyager 2 to Earth take approximately 17 hours and 25 minutes to reach our planet, and an additional 17 plus hours if ground control is to reply. Voyager 1, which is about 151 AU away from the Sun, is even further out. This equates to around 21 hours of travel time for a one-way trip. Despite their immense distance, researchers and flight controllers contact the Voyagers on a regular basis. The link, so to speak, was severed in March 2020. That's because NASA needed to repair DSS-43, a 230-foot wide or 70-meter antenna in Canberra, Australia, that can act as the probe's cosmic megaphone. The Deep Space Network, or DSN, is used by the Voyagers to transfer data and images back to Earth. The DSN is a network of massive radio antennas located all over the world. It consists of 3 communications facilities, one of which is located in Canberra. In addition to Canberra, the DSN has 2 other identical facilities, one in Madrid, Spain, and one near Barstow, California, at Goldstone Observatory. Each station is outfitted with a 70-meter, 230-foot antenna, as well as smaller radio dishes. Canberra, on the other hand, is the only facility in the Southern Hemisphere, so it has the only antenna with a direct line of sight to Voyager 2. When DSS-43 was launched in March, it was the longest cold shoulder Earth had given Voyager 2 in the previous 30 days. On the Earth's surface, the 3 communication facilities are approximately 120 degrees apart. This alignment is critical because it ensures that the majority of spacecraft may communicate with at least one DSN site at the same time. That means we never lose sight of a spacecraft while the Earth rotates. The Voyagers' photographs and other data are received by these gigantic DSN antennas. The antennas also receive information about the location and status of the spacecraft. Simultaneously, NASA uses the DSN to relay lists of instructions to the spacecraft. The robotic explorers face a significant amount of work ahead of them. They are unable to use communication equipment that is too heavy, occupies too much space, or consumes too much power. The little antennae on the Voyagers can send feeble radio signals back to Earth. A larger antenna is necessary to detect signals as the Voyagers move further away. Each DSN site's largest antenna is 70 meters, 230 feet in diameter. Because the Voyagers are so far away, their signals to the antennas are relatively feeble. In fact, the DSN antennas receive 20 billion times less power from the Voyager signals than a digital watch requires. Engineers have discovered methods to amplify such signals, allowing them to be stronger. The Voyagers collect data about their surroundings in real time and transmit it to Earth via radio waves. Once the DSN antennas receive the signals, the information centers at each DSN location receive incoming information. They are then sent to Pasadena, California's Jet Propulsion Laboratory's Space Flight Operations Facility. The photos and other data are processed and made available to scientists and the general public. Given the track record and inexpensive cost of radio broadcasts, as well as the development of distant spacecraft, NASA's DSN and others like it are certain to continue operating for decades. Voyager 2 is anticipated to keep communicating with Earth until at least 2025, with Voyager 1 perhaps reaching 2030. However, the power supplied by the radioisotope thermoelectric generators (RTG) will soon be insufficient to power any remaining instruments. Following that, the Voyagers, like the Pioneer probes before them, will continue their trek through space in silence. The enhancement's successful pings between radio antennas and spacecraft aren't usually newsworthy events, but because Voyager 2 is such a well-known and historic mission, it deserves special attention, especially in situations like this, which involves a period of one-way radio silence that's virtually unprecedented. According to NASA, DSS-43 had not been offline for this long in over 30 years. The obsolete radio antenna had been in service for about 47 years and was the only one on the planet capable of communicating with Voyager 2. As part of the refurb to accommodate the new transmitters, DSS-43 received 2 new antennas, improved heating and cooling equipment, power supply equipment, and other electronics as part of the refurb. These enhancements will safeguard the longevity of an already well-known facility, and the reason DSS-43 is the world's only dish capable of reaching Voyager 2 isn't entirely technological. As a result of the probe's passage of Neptune's moon Triton in 1989, Voyager 2's track shifted substantially southward relative to the plane of planets in the solar system, preventing Earthbound antennae in the northern hemisphere from reaching it. After its planetary mission was done, Voyager 2 was said to be working on an interstellar mission which NASA is using to discover more about the solar system beyond the heliosphere. Voyager 2 is now transmitting scientific data at about 160 bits per second. In 1992, Voyager 2 found the Nova V1974 Cygni in the far ultraviolet. An attempt was made in July 1994 to observe the impact of Comet Shoemaker-Levy 9 fragments on Jupiter. Because of the craft's position, it had a clear line of sight to the impacts and was able to make measurements in the ultraviolet and radio bands. Voyager 2 passed through the termination shock and reached the heliosheath on August 30, 2007, going approximately 1 billion miles closer to the Sun than Voyager 1. The primary objective of the Voyager spacecraft was to investigate Jupiter and Saturn. After a succession of discoveries there, including active volcanoes on Jupiter's moon, Io, and the intricacies of Saturn's rings, the mission was extended. Voyager 2 went on to explore Uranus and Neptune, and it is still the only spacecraft to accomplish so. The current goal of NASA's Voyager interstellar mission is to extend its exploration of the solar system beyond the region of the outer planets to the outer boundaries of the Sun's sphere of influence and possibly beyond. The Voyager interstellar mission may be able to collect relevant interplanetary and potentially interstellar fields, particles, and waves, research data until roughly 2025, when the spacecraft's ability to generate enough electrical power for continuing science instrument functioning will be exhausted. The Voyager Golden recordings are 2 paragraph discs that were aboard both Voyager spacecraft when they launched in 1977. The records are made up of sounds and sights designed to depict the diversity of life and culture on Earth, and they are meant for any intelligent extraterrestrial life form that finds them. The records function as a time capsule. The contents of the NASA record were chosen by a team chaired by Carl Sagan of Cornell University. The content of the record was decided over a period of about a year. Sagan and his colleagues amassed 115 pictures, as well as a variety of natural noises, such as those created by surf, wind, and thunder, as well as creatures such as bird and whale songs. To reflect humanity, they augmented this with audio content. Spoken welcomes in 55 ancient and modern languages, including an English greeting from the former UN Secretary-General Kurt Waldheim and greeting from Sagan's 6-year-old son, Nick. Footsteps and Sagan's laughter are among the other human noises, as are the inspirational phrase per aspera ad astra in Morse code and musical selections from many cultures and eras. The record also includes a printed letter from the former US President Jimmy Carter. The spacecraft will be encountered, and the record will be played only if advanced spacefaring civilizations exist in interstellar space, Carl Sagan wrote, but the launch of this bottle into the cosmic ocean reveals something exceedingly promising about life on this planet. The Future of Voyager 2, several pieces of technology aboard the spaceship have been turned off as the RTG's power gradually diminishes. In 1991, the PPS was the first piece of science equipment on Voyager 2 to be shut off, saving 1.2 watts. Voyager 2 will pass Pioneer 10 in 2023, becoming the second farthest spacecraft from the Sun at a distance of around 12 billion miles. Voyager 2 is expected to send out weak radio signals until 2027, 50 years after the launch. It is not aimed at any particular star, but it will pass within 42,000 light-years of the star Ross 248. If Voyager 2 is left alone for 296,000 years, it will pass the Sirius at a distance of 4.3 light-years. The terms of the galactic merger would also determine the fate of the Voyagers. Even if science data is unlikely to be collected after 2025, engineering data may be kept for several years longer. The two Voyager spacecraft could remain in the Deep Space Network's range until roughly 2036, depending on how much power they still have to relay a signal back to Earth. That's all for today. Thank you so much for taking the time to watch this. If you enjoyed the video, please like, share and subscribe to our channel for more such exciting content and videos and up-to-date information. See you in the next video.